Hi, welcome to Simplifying Radicals. Let's take a look at these first three problems. We have the square root of 18. So before I show you how to simplify it, let me talk to you about the radical sign. This is the radical sign, and it's understood here, if there's not a number, that this is the square root of 18. So the square root means that there's a 2 out here, the square root of that number. If you see a 3 here, that would be the cube root. So we're going to take the square root of 18. The little number that's outside the radical sign is called the index. So when you don't see an index, it means you're finding the square root. One way that's really simple that I think you can use with most problems is to create a factor tree for this number. So 18 is 9 times 2. We're going to factor into its primes. 9 is 3 times 3, and then that 2. Those are the primes of 18. I'm going to put them all back under the radical sign. Now, when you're taking the square root, if you find 2 of a kind under the radical, kind of like playing cards, if you find a pair, then one of them comes out. So these 3's come out as 1 3, and then you're left with the 2 by itself under the radical sign, and this is the answer, is 3 square root of 2. Another way that you could think about this problem is 18 has a perfect square, which is 9. So if you think about the perfect square times the other number, which this one happens to be a prime number, 9 is a perfect square, so you could kind of think about it separated like this. And the square root of 9 is 3 times the square root of 2, and you don't need the little multiplication sign there. And so you get the same answer, 3 square root of 2. Let's take a look at the square root of 72. So 2 ways to do it. You can think about, oh, the square root of 72 has 9 times 8. Well, 9 is a perfect square, but 8 also has a perfect square in it. So 8 you could think of as 4 times 2. This is a perfect square. All these are multiplied. The square root of 9 is 3 times the square root of 4 is 2 times the square root of 2. And 3 times 2 is 6. And then the square root of 2. Now let's take a look at it that first way that I was talking about, where you do a factor tree. I think these are fun, and it'll help us understand the next problem too. So if you factor 9 into its primes, you get 3 times 3. I like to circle them when they're prime. And 8 factors into 2 times 2 times 2. Alright, so we're going to put all of those under a radical sign in numerical order. Okay, now we're going to look for pairs. So when you get 2 of a kind, one of them comes out. So a 2 comes out, and here's another pair of 3's, so a 3 comes out. Now, when they come out and they bump into each other, you multiply. So 3 times 2 is 6, and then this one is still left inside, and we're going to keep it there. So we're going to get the same answer, 6 square root of 2, just a different method. All right, let's take a look at this next problem. We've got the square root of 24m squared. So let's think about going on ahead and factoring it into its primes. And m squared is m times m. 6 is 3 times 2, and 4 is 2 times 2. So let's put all of that under the radical. I didn't put it in numerical order this time, but that's all right. And so here's a pair of 2's. So a 2 gets to come out on the outside. Well, here's a pair of m's. So an m comes out on the outside. They bump into each other. You multiply. 2 times m is 2m. Now let's see what's left over. We have a 3 and a 2 inside. So you're going to multiply the leftover 3 and the leftover 2, and you're going to get 6. You're going to keep that in the radical. So this is your answer, 2m square root of 6. Let's take a look at a couple more problems. All right, all these problems are fractions. In this first one, I like to think of these separated. One of the things that's important to do is look at your fraction and see if it can be simplified. and this one can't. So because it can't, I'm going to break it apart so I can kind of think about this like two separate problems. 13 is already prime, so I can't factor it. I can't do anything else to it. There's no perfect squares. 36 it is a perfect square, 6 times 6. So I can think about it like this part's done, and then 36 is 6 times 6. So there's 2 here, so a 6 comes out, and the radical sign disappears. And that's your answer. So pretty easy. Let's take a look at this next one. So 15 factors into 5 times 3. Well, there's not two numbers that are the same. It doesn't contain a perfect square. Well, 16 is a perfect square. So you can actually keep them broken apart like this. The square root of 16 is 4 times 4, and that's your answer. Let's take a look at this last one. 32, and then break this one apart. Okay, so 32, if we factored it into its primes, that would be 16 times 2. And 16 breaks up into 2 times 2 times 2 times 2. And so then we still got this 2. If you put it all in a radical sign, there's 2 pairs that are the same. That 2 comes out. That 2 comes out. They bump into each other, and you multiply, and you get 4 square root of 2. And then on the bottom, you have 2 n, so this equals n times n. Well, there's a pair, so an n comes out. So that's actually your answer. Let's look at this one other way. All right, we said that 32 had a perfect square in it, and that was 16 times 2. So if you think about this, then 16 is a perfect square, so you can kind of break them apart and think about them like that. So this would be 4 times the square root of 2, and then we said that n times n, there's 2 of them, so 1 comes out. And we still get the same answer. It's just a different method, so you should pick whichever one you like. All right, let's try 2 more problems. Okay, 63 has a perfect square in it. So we get 9 times 7, and then this would be m times m. So 9, the square root of 9 is 3, and then times 7, and then we have 2 m's here, so one of them comes out, and it would be right there. Let's look at it the way where we factor it into its primes. So 63 is 9 times 7, break that down into a factor tree. There's all the primes, put it in a radical, your m's, they break apart. Sometimes it helps to see them all together like this. Here's a pair, so the 3 comes out. Here's a pair, so the m's come out, and m comes out, and m times 3 is 3m, and that 7 that you're left over with just stays in the radical sign, and that's the answer. One more. In this problem, again, let's break it apart. So we have 28f squared over the square root of 9. Well, we already know that the square root of 9 is 3. So I'm going to put my answer for my denominator there, and we're done with this part of it. So we got the denominator is 3. Now let's break 28 apart. That would be 7 times 4, and 4 breaks into 2 times 2. So these are all my primes, and then 2 f's. And if we put it all into radical sign, get 7 times 2 times 2 times f. There's a pair of 2's, so a 2 comes out. There's a pair of f's, so an f comes out. The 2's already waiting for it, so 2f square root of 7, and that goes on top. And that's your answer. And this is some of the basics to simplifying radicals. Thank you for watching, and check out my other videos online.